So let's continue with part 2 of question 1. All right, so we have part 3 here, which is saying calculate the range of the values of x for which 2x plus 8 is greater than 5x squared minus x cubed. Now recall, all right, that our f of x in factor form is x plus 1, x minus 2, and x minus 4, right? Okay, so now guys, see, when you're given this question, what you're going to do is that you're going to take everything on this side. All right, going to take everything on that side. So we have a 2x plus 8 greater than 5x squared minus x cubed. If I take everything on the other side, the negative will turn into a positive, right? Then the positive will turn into a negative, plus 8x plus 8 is greater than 0, isn't it? Now guys, if you look at this carefully, all right, this is the same as f of x. All right, if you look at the question, so f of x is greater than 0. Okay, so whenever you have the power more than 1, like 2, 3, 4, 5, 6, this, if you see this and you see an inequality, it becomes what? Inequalities. All right, and how do you solve inequalities? So whenever you see a power of 3 and an inequality, immediately you should write critical points. All right, critical points. So after you write critical points, you're going to equate this to 0. You're going to remove the inequality symbol, so you're going to have x cubed, all right, minus 5x squared plus 2x plus 8 is equal to 0. Right, then this you're going to express it in factor form, and you already have the factor form for this. What is a factor form? It is x plus 1, x minus 2, and x minus 4 will be equal to 0. Then I'll solve for x, so my x plus 1 will be equal to 0, and my x minus 2 will be equal to 0, my x minus 4 will be equal to 0. So this will be x is equal to negative 1, x is equal to 2, and x is equal to 4. All right, so these are your critical points. Okay, these are your critical points, and as I've been repeating in the previous video, I even said if you don't know how to find even critical points, just go in ZFuse application, all right, and go to inequalities. You'll find all these videos in inequalities. And how do you access ZFuse? You go on Play Store. All right, for now it's on Play Store, and then download, of course, install, go and sign up. When you go and sign up, don't enter your details, go straight to register with Google. All right, with Google, if it tells you email already exists, after you do this, just go and log in. If you fail to log in, then try forgetting your password. Forgot password. If you forgot your password, enter your email. When going to check your email, go to your spam. You'll find your email there. Your spam is just at left top corner, my 3 buttons that are there. Just press those on your email, you'll find spam there. Anyways, let's get back to our question. So we have these critical points. So after the critical points, you're going to go on a number line, right? On a number line. There's a number line. So you're going to write the smallest is negative 1, the second smallest is 2, the third is 4. All right, so I'll pick a value which is less than negative 1. What value am I going to pick which is less than negative 1? I'll pick negative 2. I'm going to say let x be equal to negative 2. Now this negative 2, I'll replace it here, here, and there. All right, where I took the critical points from. So I'm going to have negative 2 plus 1, negative 2 minus 2, negative 2 minus 4. Now negative 2 plus 1 is negative, negative 2 minus 2 is negative, negative 2 minus that is negative. I only care about the signs. For example, negative 2 plus 1 is negative 1, but I'll not take negative 1. I'll take negative, right? Negative 2 minus 2 is negative 4. I'll take negative. If that is negative 6, I'll take negative, right? Now, negative times negative is positive. Positive times negative. Negative times negative is positive. Then positive times negative is negative. So the answer here is negative. So if this is negative, this will be positive, negative, positive. The signs will alternate. Okay, so if this one was positive, this would have been negative, positive, negative. All right, that's how it is. So now after you do this, guys, what you need is to This is negative. Yeah? I made a mistake. Positive, negative, positive. They have to alternate, right? Yeah, the sign here is negative, sorry. Okay. So it should be negative, positive, like that. Very good. Okay, so now after this, guys, after you fill in the signs here, you have to go back to your question. What is your question saying? Your question is saying your f of x should be greater than what? 0. Why the opening is greater, like this. Why what is here is greater, what is on the tail is less. That's the way it is. So if I write like this, what is here is less, what is here is greater. That's the way it is. Now look at this. Our f of x is to the opening of an inequality, right? So meaning f of x is greater than 0. Now which sign is greater than 0? The negative sign or the positive sign? These, which ones are greater than 0 here? Is it the positive sign or the negative? Notice that it's the positive signs which are greater than 0 on a number line, right? Negative is this side and positive is this side. All the positives are greater than 0, isn't it? So I'm going to pick a region where I find positives. So my answer is in that region. Here it's false. Alright, this is false and this is false. So my answer will be between -1 and 2 union, because there's a gap from 4 to positive infinity. Here it's positive infinity, here it's negative infinity, isn't it? From 4 to positive infinity. Now all these brackets will be curved. Why will these brackets be curved? Because our question does not have an equal to symbol. What I mean is there's no equal to symbol here, so everything will be just in curved brackets. So this is the answer to this question. Okay, so now let's go to the other question. The other question is saying calculate the rational function. Okay, so we have part 2, which is we have x squared plus 2 over x minus 1. They're telling us to sketch this. Okay, sketch the rational function f of x is equal to that. Alright, so guys, when you're sketching, what do you look for first? You look for the vertical asymptote. Alright, vertical asymptote. Alright, and how do you find the vertical asymptote? You say let x minus 1 be equal to 0 and our x will be equal to 1, right? That's a vertical asymptote. You equate the denominator to 0 always. Then you have to find your horizontal asymptote or oblique. Now, how do you differentiate that? If the power that is on top here is greater than the power that is down, if the power of the numerator, the power of x of the numerator is greater than the denominator, meaning you're going to have an oblique. Alright? And how do you achieve an oblique? So you're going to use long division. Alright? You're going to write your x minus 1 here. You're going to write your function here, which is x squared plus, since you don't have x, you're going to have 0x plus 2, right? Because from x squared you have to go to x, and you don't have x there. So now I'll divide this into this. X into x squared is x, right? Then I'll open a bracket with a negative. Then I'll multiply x times x is x squared minus x. Alright, so you divide this into that, you're going to have x, then you multiply this with everything that is here. So x times x is squared, x times that is negative x. Then you are going to subtract the like terms. So x squared minus x squared is 0. Negative times negative is positive. 0x plus x is x. Right? Then these two will fall down here. Plus 2. Alright? Then I'll continue dividing. X into x is what? Plus 1. Then I'll open a bracket with a negative. 1 times x is x. Minus 1 is that over. Then x minus x is 0. Negative times negative is positive. 2 plus 1 is 3. So 0 plus 3 is 3. Now this is called error of x, which is a remainder, isn't it? So now what will be your oblique? Your oblique, alright, will be y equal to the quotient. So what is our quotient in this case? Our quotient is x plus 1, this one here. All the numbers found here are called quotients. Alright, quotients. Alright. Okay, so if you want to understand this, I've been preaching too much about Z-phase. Alright, so just go on the same and follow the instructions. You really benefit, okay? You really benefit. You really benefit. Okay, so let's continue. So we have our oblique asymptote and a vertical asymptote. The next is to, since our oblique is a linear function, if you notice there is x plus 1, how do you sketch a linear function? You sketch a linear function by finding its intercepts, right? The x and y intercepts. So x and y, like that, okay? So I'm going to say when this is 0 and when that is 0. So when x is 0, my y is 1. When y is 0, my x is negative 1. So what am I going to sketch? I'm going to sketch this, and I'm also going to sketch the vertical asymptote. Where is it? Where is my vertical asymptote? Okay, this guy here. Okay, so now let me sketch. All right. So now we're going to approximate what is the vertical asymptote. Your vertical asymptote is x is equal to 1. So I'm going to approximate that your 1 is here. And then how do you sketch this? This is 0, 1. So I'll approximate that my 1 is here. And this one is negative 1, 0, which is here. So I'll join these two lines. I'll join these 2 points. Okay, you can use a ruler. Which this is bend, right? Okay, this is more like it. Okay. So now here, guys, how do you sketch this now? So this is your oblique. How do you know this point? Okay, since x is 1 and this is the oblique, okay, and x is already 1. So to get the y value here, what do you do to get the y value? What do? You need to get the y value. Here x is 1. Alright, to get the y value, I'll take this 1 and replace it here. 1 plus 1 is 2. So this point is 2. Okay, so now guys, let's sketch. So here, you're going to take values before the vertical asymptote. Values here. Alright, you can take one value before the vertical asymptote. And also values after, this is 2 rather, after the vertical asymptote here. You can pick any value, just one value is enough. So before the vertical asymptote is 1, so I'll pick a value before it. What value can I pick? I'll pick 0. 0 is the best. So I'll say let x be equal to 0. So I'll replace here. I'll replace 0 there. So 0 squared plus 2 over 0 minus 1. And the answer is negative 2, right? So I'm going to have 0, negative 2 as my y value. So 0, negative 2 is found here. Have you noticed? Okay. So when x is 0, y is negative 2. So now since it's a point inside this triangle here, so I'll just follow the oblique like that and follow the vertical. That's a graph. That's a point before. So in other words, this tells you that all the points before x is equal to 1, all the points in here will just be in this same guy here. Now let me pick a point after. So I'm going to say let x be equal to 2. Right, 2. So I'll replace it there. 2 squared plus 2 over 2 minus 1. And the answer will be 6 over 1. And the answer will be 6. Now when x is equal to 1, or when x is equal to 2 here, y is 6. Now how can you find 6? 6 is a point inside here, right? Somewhere there. So now since the point inside the triangle, you're just going to follow the vertical and the oblique like that. Just going to follow this. Okay, that's a graph. Now what if it was a point outside here? Well, we would have just followed outside this and that. That would be your graph. So that's how you sketch this, guys. So yeah, that's how you go about this. And if you need more understanding and more clarity, don't hesitate. All right, physics and chemistry, all right, and chemistry in the ZFuse app is made by lectures, so don't hesitate to just have it on you and go and enjoy the experience of more videos for this. So let's go to question 2, guys. Let's go to question 2 and we'll see how it goes.